Hello dear viewers and welcome to this video lecture series. In this video lecture we are going to learn the inline function. Okay, let's see what is the inline function. So I'm having a couple of theory over here. Let's open side by side. Okay, so whenever you're using a classes, whenever you're declaring a function inside your class like this. So by default when you're defining and declaring the function inside the class, it's inline. So I've got the program with the two version. One is having a function body outside the class and second is inside the class. This is the same previous program which we have used to demonstrate the concept of a class in the last video lecture. So now let's see that what's the difference between these two. Though you got the output, same output in both of the case, but there is the difference in the implementation at the back end. Okay, so let's see that what is the inline function first. So inline function, so this is the theory. Refer to my the function video for the detail, the stack and another register variables. So now it's a overhead. If your function is very small, so this is a very large overhead to storing all that data and other stuff. Okay, so C++ provided inline function to reduce the function call overhead. So whenever you are using an inline function, then the copy of the function is going to be uh, substituted at the time of a function call. So you can see that the whole code of a inline function get inserted or substituted at the point of a inline function call. Right? So this is the request to the compiler, not to the command. So compiler can ignore the inline mechanism. Now these are the some cases in which compiler is ignoring your inline request. Okay, so first is the if your function contains the loop. Second is if it contains some static variable. Third is if the function is a recursive function. If it contains switch and go to, then in each and every these cases it's going to ignore the inline function. Okay, so let's see the difference between the inline function. So I'm having this program, both of the program. Let's execute this program. This is not a inline implementation, so these are treated as a non-inline function. So to demonstrate the concept, so I'm going to call these two functions over here several number of times so that we can see the difference. I'm going to paste it several number of times, input and the show. These are two functions. I'm going to call it 1 2 3 4 5 6 1 2 3 4 5 6 7 42 times. I'm calling the function near about 84 120 30. Maybe I call this function 200 times, so I'm going to copy whole stuff. Okay, so this was my function call. I'm going to copy it. Okay, let's execute this program. So I'm not going to initialize all that show and input mechanism. I'm just compiling this code. This is a hello.cpp, and second is member function inside the class. If it is inside the class, then it's treated by default as an inline function. So I'm going to replace it with the same number of function call. I just paste all that stuff of from this program and I have pasted it over here. So again I'm going to compile this over here. So just ignoring the input. So you can see I'm having a two exe file. One is from the hello and second is from the memory. Fine. Okay. Let's see the difference. Okay, so size is approximately these bytes, these number of bytes. Let's compare it with the notepad. So this is from the hello program. Fine, it's containing this much of a byte. And if I'm going to go for the second version, so here I'm having these much of bytes. That is so. Okay. So now you can see clearly in the second version. So I'm having approximately okay. Let's take a difference 198322 minus 1982719. So nearly 497 byte difference. So now hello is consuming a less memory rather than the second function, second program in which I have declared the function inline. So now, though your program execution, okay, let's check the compile time. It's take 1.64 seconds and it is taking almost the same. But if program is larger, your inline function may get less time, as it's just copy the code at the time of the calling, rather than that overhead is eliminated in case of inline. But it's a copy, it's making a copy of a same function several times over here. So that's why it increase its code, a binary code. So that is the reason this mem function is having 497 more uh, bytes than this function. So now we are having a keyword. So let's suppose I have declared this function outside the class and I want to make it inline. So simply you have to write a keyword inline. It doesn't matter you are writing inline before void or after void. It both will work in our case. So now I have converted even the hello program to the inline. So let's again compile this code and okay, I'm not going to give the output. Rather, I'm interested in uh, checking the size. So now this is your hello program, but at this time I made that function as an inline. Now you can compare the both of the files are having a same number of bytes. So uh, so in this we are having some advantages and disadvantages. The advantage is that your program, if it is inline, your program will execute a little bit faster, but you have to compromise with the space. So this inline function is at the backend implementation. So there is no difference in our output. So thanks for watching this video and keep tuned to my next video. Subscribe to my video lecture so that you will get an update. Thanks for watching.